Hi everyone, in this video we're going to go through hopefully questions 5 to 10, we'll see how we go from 10Gs, so let's get stuck into it. So question 5, aligned with equation y equals mx plus c is a tangent to the curve y equals x minus 3 squared at point P where a is between 0 and 3. Okay. So question A, find the gradient of the curve at x equals a for a is between 0 and 3. So what we can do is we just need to take the derivative, first of all, of x minus 3 squared. It's quite an easy one to expand if you wanted to do that, or you can use your chain rule, but I'm just going to do it on the calculator. If I can find the function I want, I can't find anything. Okay, so we've got x minus 3 squared. All right, so we're left with, I'll just get my pens ready. All right, so dy dx is equal to 2x minus 3. All right, not a hard one to do by hand, but we'll do it on the calculator. So part I, find the gradient of the curve at x equals a. So at x equals a, dy dx is equal to 2 times a minus 3. We can expand that if we want to, so that becomes 2a minus 6. Hence express m in terms of a. So remember, m is in your linear equation and m is your gradient and dy dx is your gradient. So m is also 2a minus 6. All right, so that was part 1 and part 2 of that question. All right, question B. State the coordinates of the point P expressing your answers in terms of a. So here's point P. So point P is a y, and all we need to do is substitute in a. So let x equal a. That means y is equal to a minus 3 squared. And if we expand that, we're going to get a squared minus 6a plus 9. The reason I've done that is because that's how the solution is in your textbook, and sometimes it's good to be consistent. All right, question C, find the equation of the tangent where x equals a. So I'm just going to write C down here. All right, so what we need for our tangent equation, remember it's a straight line, so y equals mx plus c. So I know that our gradient is 2a minus 6, and our points x, y, so x is equal to a, and y is equal to a squared minus 6a plus 9. So all I need to do is substitute those values in and solve for c. So I've got a squared minus 6a plus 9 is equal to m times x. I'm just going to put the x out the front, so 2a minus 6 plus c. Now, if you like, do that on the calculator. So I'm going to go to solve, and the reason I'm doing this on the calculator is because there's so much going on. I don't want to make a mistake, so let's just do this. 2a minus 6 plus c, and we're solving for c. So c is equal to, what have we got? Negative a, oh gosh, this is a long one, 2a minus 6 plus a squared minus 6a plus 9. And let's see if we expand this, whether we can cancel some things out. So let's just expand this. We get negative 2a squared plus 6a plus a squared minus 6a plus 9. So they cancel out, and then I'm left with just, we put the positive number first, 9 minus a squared, because I've got negative 2a squared plus a squared, so 9 minus a squared. And then we can put everything back into our equation. So we've got y equals m, which is your gradient, 2a minus 6. So I'm going to put that in brackets. X, and then the value of c is 9 minus a squared, so plus 9 minus a squared. All right, question D. Find the x-axis intercepts of the tangent. So D. So if we're finding the x-intercepts, we're letting y equal 0. And I can just do that on the calculator. So we'll go to solve again. So I should write what we're actually putting into the calculator. So 0 equals 2a minus 6x plus 9 minus a squared. All right, 0 equals, and then 2a, oops, 0 equals 2a minus, 2a minus 6 times x plus 9 minus a squared, and we want to solve for x. So your x-intercept is at x equals a plus 3 on 2. Now I'm just going to make sure they haven't given us a value of a. No, so everything is just in terms of a. So your x-intercept is there at a plus 3 on 2. And if we're writing that as coordinates, x plus 3 on, whoops, not x, sorry, change that in a second. A plus 3 on 2. All right, moving on to question 6. So question A, the graph of f of x equals x to the power of 4 is translated to the graph of y equals f of x plus h. Find the possible values of h if f of 1 plus h equals 16. All right, so we'll just do question A. All right, so f of, excuse me, 1 plus h equals 16. So all we're doing is substituting in 1 plus h into x to the power of 4. So x equals 1 plus h to the power of 4. And then we've got to take the fourth root of both sides. Now, because it is a even power or even root, we're going to have plus or minus. So the fourth root of 16 is 2, so we're going to have plus or minus 2 equals 1 plus h. I prefer to put the h on the left-hand side, so I'm just going to switch that over. All right, and then minus 1. So h can equal 2 minus 1 or negative 2 minus 1. So h is equal to 1 or negative 3. All right, moving on to question B. So the graph of f of x equals x cubed is transformed by the graph of y equals f of ax. Find the possible value of a if the graph of y equals f of ax passes through the point with the coordinates 1, 8. All right, so I'm just going to do question B over here so I can still see the question. So we've got f of x equals x cubed, and we're going to transform it by ax. So that means instead of x, we're going to have ax cubed. All right, find the possible value of a if the graph of y equals f of ax passes through the point with the coordinates 1, 8. So that means f of... All right, so we've got f of ax is equal to 8. So when x is equal to 1. So I'm just going to put 8 equals and then substitute the 1 in. 8 times 1 cubed, oh, excuse me, So 8 is equal to a cubed. So a is equal to the cubed root of 8, which is 2. All right, question C. The quartic function with the equation y equals ax to the power of 4 minus bx to the power of 3 has a turning point with the coordinates 1, 16. Find the values of a and b. All right, so we've got two unknowns, a and b, so we need to have two equations. So if we've got a turning point at 116, that means that point is on the curve. So let's substitute that in first. I'm going to have to do a bit of scrolling. All right, so what do we got? Actually, I must make it smaller so I can read it. Y equals ax to the power of 4 minus bx cubed, and we've got the point 116 as a turning point, which is the same as a stationary point, so that helps. All right, so the first equation, what we're going to do is just sub in 116. All right, so we've got 16 equals, I'm just going to do this in one go, so a minus b, okay, when we substitute 1. So that's one equation. Our second equation comes from finding the derivative, so dy dx is equal to 4ax cubed minus 3bx squared. Now I know that the gradient dy dx is equal to 0 when x equals 1. So I just now need to substitute in 1 and let that equal 0. All right, so I'm going to have 4a minus 3b is equal to 0. And I'm getting really distracted by my son who's downstairs singing. All right, so now we've got two equations. We've got, and I might just rewrite it here, a minus b equals 16, and our second equation, 4a minus 3b equals 0. Now we could easily you do that by hand, but I'm just going to do it on the calculator. And I did one of these the other day and I chose the wrong thing. So let's make sure I choose the right one. Is that the one? Yes. Okay, so we've got a minus b equals 0. And the second one is 4a minus 3b equals 0. So the first one wasn't 0, it was 16, sorry. Just realised it could both be. Now can we do a minus b? Yeah, cool. So a is equal to negative 48 and b is equal to negative 64. All right, question 7. Consider the cubic function with the rule f of x equals blah, 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 where a is greater than 1. Question A, find the coordinates of the turning points of the graph of y equals f of x. So whenever we see turning points, we need to calculate the derivative. So we're going to find f dash x. Now you could use the product rule. I'm just going to do it on the calculator. So I always have trouble finding which menu it is. Okay, so we've got x minus a to the power of 2, not 62, sorry, power of 2, and then x minus 1. All right, so I get 3x squared plus a squared minus 4ax minus 2x plus 2a. Okay, so if we're finding the coordinates of the turning point, remember your turning points are at f dash x equals 0. So I'm going to do that now on the calculator. So we can just go to, oh, there it is, solve. And I'm going to highlight all that, drag it down, and we're going to let it equal 0. And we're solving for blank. So that means we have x equals, I'll do a first, and then the other one is x equals a over 3 plus 2 over 3. I really feel like I've done this question. All right, and I'm just going to simplify that to a plus 2 over 3. So we've just found the x coordinate. So it does say find the coordinates of the turning point. So what I need to do is substitute a back into f of a to get the y coordinate. Now this is where it would have been good to define on the calculator, but I'm just going to do this. So x minus a, actually, where is that? Good thing about your calculator is you can copy and paste. So there's our original function. And if I go to my no, not that. Find which menu it's in. So this one here, given that x equals a. All right, so we get 0. And then let's do f of a plus 2 on 3. So I'm going to just highlight that. Now, if you don't want to highlight, your copy button's just there down the bottom, and then you can paste. So instead of x equaling a, I'm going to change that to a plus 2 over 3. And there is my y coordinate, which is not the nicest, but anyway. A plus 2 over 3 minus 1. And then a plus 2 minus over 3 minus a squared. Now I'm going to see what happens when I expand that, if it's going to be any nicer. Oh, let's highlight it first and copy. Okay. It's not too bad. Actually, I feel like I've done this question. Maybe it's just very similar. All right, so if you want to do that in expanded form, 9 plus 4a over 9 minus 4 over 27. All right, so your 2 points are a0. Okay, so that's your first turning point, and your second point is a plus 2 over 3, and then all this. So you can choose whether you want the factorized or the expanded. We could probably tidy it up a bit, but I'm not going to because we don't have all day. All right, so yeah, there's your x coordinate and there's your y coordinate. All right, let's go back up to the question. All right, question B, third time lucky. All right, I just realized, you probably don't know because I've been editing out this section of the video, but I keep doing it incorrectly and I've realized what I've done. So let's go down and do B, the nature of the turning points. So, oops, let's get rid of that, my previous working out. All right, so if we think about what the graph looks like, so I'm just going to sketch it here. Because we've got x minus a squared, that means we're going to have a x-intercept at a, or your graph is actually going to have a turning point at a2. X minus 1 is also a factor, so if I just go back up to the equation, x minus a and x minus 1 are our factors, so that means your x-intercepts are at a and 1. But I also know that I have another stationary point, so x-intercepts at 1, 0 and a0. But I've also got a stationary point at a0 and a plus 2 on 3 and all that other stuff. Now the point a plus 2 over 3 is very helpful in determining whether it's the nature of the turning point. All right, sorry, just had to answer Katie's message. All right, so we're going to find out what is happening at a plus, or where a plus 2 over 3 is on our x-axis. So I know a has to be greater than 1, that's why a is to the right of 1, but a plus 2 over 3. So all we need to do is choose a value for a. So let's say a is equal to 2, which is this point here, then a plus 2 over 3 is equal to 2 on 2 over 3, so 4 over 3. So that means whatever value I substitute in for a plus 2 over 3 is going to be less than that. So this point here, a plus 2 over 3. So a plus 2 over 3 is somewhere between 1 and a. Alright, so I know that my graph has to have a repeated factor at a, and it also has to go through the axis at 1, and I have to have a stationary point at a plus 2 over 3. So what I can say is, well, what is my y coordinate of a plus 2 over 3? So let's say, well, if I've let a equal 2, that means my y coordinate, which is all this over here. So let's see, do I put that somewhere? On here, there it is. Okay, so there's my y coordinate, which we did earlier. And I'm just going to paste that in, and let's let a equal 2. So we get 4 over 27. So that means when a is 2, at the point, when a is 2 on the point a plus 2 over 3, so when it's 4 over, actually just give me 1 sec. All right, so sorry, I'm just thinking, so when we let a equal 2, so this point here is 2, and the point in the middle, this point here, is going to be 2 plus, sorry, didn't mean to cross it out, I meant to highlight it. This point here is going to be 2 plus 2 over 3, and when we substitute that in, we get a positive value for y. So that means the coordinate is going to be up here. Right, so it doesn't matter what value of a we use, we just needed to know whether this point was going to be a positive y coordinate or a negative y coordinate. So we just found out it's positive, so 4 over 27. So that means when I go down to here, I'm going to have a repeated factor at a, and then this graph is going to go down like that. So at a, it's a local minimum. Now I was just realizing when I was drawing that graph that our cubic up here is also a positive cubic. So that could have helped us. I guess the hard part is determining where a plus 2 over 3 fits on your x-axis. So if I know it's between 1 and a and it's a positive cubic, it's got to look like that. It doesn't matter what your value of a is, it's just going to change the graph slightly, but you're always going to have a repeated factor at a and a turning point at a plus 2 on 3, which is between 1 and a. All right, so a bit tricky that one. Question C, find the equation of the tangent to the curve at the point where x equals 1, x equals a, and x equals a plus 1 over 2. So finding the equation of the tangent to the curve at the point where x equals 1. All right, so let's just pause this. All right, so we need to find the derivative again, but what I'm going to do now, and what I should have done at the beginning, is define the function. So I'm going to define f of x is equal to x minus a squared, x minus 1. All right, so I'm just defining that function. Now, if we're finding the tangent at the curve of x equals 1, so remember I can go in and, what was it? There we go. Calculation line, tangent line. Could probably just do this, f of x at x equals 1. So there's our equation there. So I'm not going to go into that by hand because it's going to take forever. So this one here is y equals x times a minus 1 squared minus a minus 1 squared. And you could probably take out a minus 1 squared as a common factor, just looking at that. So a minus 1 squared, oops, didn't mean to put that bracket there, times x minus 1. Right, is another way of writing that. Alright, so when x equals a, so I can just highlight that and then just change, instead of having 1, put in a, and there is your tangent line, it's 0. So that means it's y equals 0. And when you think about it, a is undefined at that point because a has to be greater than 0. And also if we let a equal, x equal a, we're going to have a minus a, and then we're just going to be left with a linear function anyway. Alright, and then the last one, let's just go down and type in a plus 1 and divided by 2. Oh, and there it is, it's quite long. Alright, but, oh gosh, look how long it is. Let's see what happens when we expand it. Okay, so we get all that, and you could probably see some repeated factors there. So I'm just going to write a cubed over 4 minus a squared x over 4 minus a squared over 2 plus ax over 2 minus x on 4 plus a on 4. And I'm sure I could easily tidy that up. Actually, what I might do is just have a look at what they had. Oh, my son's doing. Hopefully the dishes are not cooking. Alright, so you can actually see there it's y equals 1 over 4 times a minus 1 squared times negative x plus a. But if I was to do that, all that working by hand, this video would be extremely long. Alright, so if you're interested in looking at the working out, there it is in the solutions. Alright, let's have a look at the next, finish that question, the painful question. Alright, so question 8, 9 and 10 I might just leave for another video just because I'm a bit conscious of time. So I'm going to change this up here. So I've just done questions 5 to 7. Oh my gosh, how exhausting. Alright girls, bye.